Today's objective is to be able to simplify expressions by combining like terms and using the distributive property. So basically, we're going to be reviewing the skills that you already learned before in order to prepare you for your independent practice that you have to complete today. So let's look at example number 1. In the example number 1, it says simplify the following expression. That means that I have to either distribute first if there's anything that needs to be distributed, and then I also have to combine like terms. So those are the two things you always want to be looking out when they ask you to simplify those expressions. Do you have to distribute, and can you combine like terms? In this case, when I scan my expression, I see that there are no parentheses. So there is no need for me to distribute anything. Therefore, I can go into the other and do the other part, which in this case would be combining like terms. So that means that I have to identify the different families, the different terms that come from the same family, so that I can go ahead and combine them and make this expression simpler or shorter and much easier to work with. So the first thing that I'm going to box is this positive 4 that I have here. Now I'm scanning the rest of my expression so that I can see if there are any other terms that come from the same family as the family of 4. And I know that 4 comes from the family that has no last name. It does not have a variable next to the coefficient. Therefore, I'm looking for another term that also does not have a variable. And when I scan the rest of my expression, I see that -3 does not have a variable as well. Make sure that anytime you're boxing your numbers, anytime you're boxing anything from other families, that you are including its sign. You guys are getting a lot of answers that are incorrect only because you're forgetting to include the negative or positive signs that comes along with that term. So now I can combine these two things, and on the side I'm going to show the work that I'm doing. So on the side I'm going to show that on my calculator I'm actually adding 4 plus -3. Now remember, the only operation that we're using when we're combining like terms is addition, whether you're adding two positive numbers, two negative numbers, or a positive and a negative. Now when I add this positive and negative number, 4 plus -3, that's going to give me a positive 1. Okay, that means that these two things combine to give me a positive 1. So now I'm going to go ahead and circle this next term, this positive 2x squared, and again, I'm including its sign. So now I'm searching and I'm scanning the rest of my expression to look for something that comes from this same exact family. That means that if I'm looking for something that comes from the same family as 2x squared, I need another term that has the variable of x, but also must also have an exponent of 2. Just because it has a variable of x doesn't mean that it also comes from the same family as 2x squared. It must also have the same exponent. So in this case, if I search the rest of my expression, the other term that comes from the same family as 2x squared is this positive 5x squared that I have over here. So since I see that they both have the same variable, meaning the x, and they also have the same exponent of 2, I can go ahead and combine them. Notice that I did not combine it with this and this because x and 8x do not have an exponent of 2, therefore they do not come from the family of 2x squared and 5x squared. But I can combine these two terms that I've circled here in green. So most people are able to identify that these two terms come from the same family. However, one of the most common mistakes that I saw as I was grading your work is that we are not correctly combining things that have variables with exponents on them. So most people saw these two terms, and some people did this in order to combine them. They did 2 squared plus 5 squared to then give them a total of 29. However, this is incorrect, okay? Remember, when we are combining like terms, we are simply just taking their first names and adding them together. So I'm taking the first name from 2x squared will be just a 2, and I'm adding it with the first name of this 5x squared, which is just simply the 5. When I add those two things, that's going to give me a 7, which is a positive 7. So all I have to do is write down this positive 7, but its last name continues to be the same. So 2x squared plus 5x squared is just simply 7x squared. We do not square their first names when we are combining like terms. We only add the first names that are already there. So that's what this gave me. Now I'm going to go ahead and put this positive x in a triangle so that I can look for the family member that goes along with that one. And remember, there's always a 1 here that we don't usually write. As I scan the rest of my expression, I notice that there's a negative 8x here, which means that they both come from the same family. So again, in order for me to combine these two things, all I'm simply going to do is take the first name from 1x, which in this case is a 1, and add it with the first name from this negative 8x, which in this case is a negative 8. I didn't square these, I didn't do anything to the first names, all I did is take them so that I can add them. Now when I add these two things, that's going to give me a negative 7. So since it's a negative number, when I combine them two, I'm going to get minus 7 and keep the last name of x. So now I'm looking to see, okay, is there anything else that I can combine in this expression, or am I done with the terms that come from the same family? Well, 1 comes from the no last name family, and there's nothing else that I can combine that with. 7x squared has a last name of x squared with an exponent of 2, and I see that nothing else has an exponent of 2. And negative 7x has a last name of x, and there's nothing else with the same last name either. So since I can't combine any further, then that means that I've simplified this all the way through. So my final answer is 1 plus 7x squared minus 7x. The main takeaway from this problem is to remember that you are not squaring the coefficients. You are simply adding the coefficients, adding those first names when you are combining like terms. So here's another example where they're asking us to simplify the expression. So again, the first thing that I want to check is there anything that I can distribute? And once I distribute, I want to check, is there anything that I can combine? So when I look at this expression, I have 3x minus parentheses 5 minus x plus 2. So I see that I have parentheses, so automatically that tells me that there's some sort of distribution that has to go on here. If you notice, there's a minus sign between my parentheses and the 3x. So again, that should tell me that I cannot distribute that 3x to the 5 minus x. Instead, I'm looking to check what number is exactly next to my parentheses with nothing in between so that I can distribute it to the 5 minus x and free it in order to combine my like terms. In this case, the number that's right next to the parentheses is actually this negative 1. Remember, anytime you have a plus next to a parentheses or a minus next to a parentheses, there's always a 1 there that we just don't usually write. However, since we already know it's there, our job is always going to make sure for us to write it ourselves. So now I can go ahead and start distributing. Now, if I begin with the first term in my expression, this 3x, I notice that I'm not doing absolutely anything with it, so I'm simply just going to write it here to the side on the same line where I'm going to be doing my work, just so that I know that I won't be forgetting it. So I'm going to take this negative 1 now, and I'm going to distribute it first to the 5. So I have negative 1 times 5. Then I'm going to take my negative 1 and distribute it to this negative 1x that I have over here. So I have negative 1 times 1x. Now notice that I did not distribute my negative 1 to this positive 2. This positive 2 is not inside of my parentheses, so it's not being multiplied by that negative 1 or that minus sign that's there. Okay, since I've done nothing with this positive 2, I can't distribute it and I can't combine with anything just yet. I'm just simply going to bring it down as well as part of my work, so that again, that I don't forget that it's a part of my expression. It doesn't disappear, but I can't combine it with anything just yet. Now I can go ahead and simplify the multiplications that I have here. So again, I still have this 3x. Negative 1 times 5 is going to give me a negative 5. Negative 1 times 1 gives me negative 1, and I keep my x. I keep the last name. And I still have this positive 2 that I'll be working with in the next few steps. So now that I have this new expression, I have 3x minus 5 minus 1x plus 2, I can figure out what things I can actually combine. I've distributed, I've freed whatever's inside of the parentheses and taken outside of the parentheses. Now I have to combine like terms. So I have to combine things that come from the same family. So in this case, I'm going to box my first term. I have this 3x, and I'm going to combine it with this negative 1x that I have over here. So on the side, on my side work, I have 3 plus negative 1, which is going to give me 2. So in this case, when I combine them, this is a 2x. And please make sure that you are adding these numbers and you're double checking your calculator to make sure that you are combining them correctly. Sometimes it's very easy to just make small computational errors. Now I have this negative 5, and again my negative 5 comes from the no last name family, which I see positive 2 comes from that family as well. So I have negative 5 plus 2, which is going to give me a value of negative 3. So these two things, when combined, give me a value of negative 3. And now I have combined like terms. I have two things that come from two separate families, which means that I am done simplifying this expression. My answer is just simply 2x minus 3. In your independent practice, make sure that you are showing all your work. You're showing me what you're distributing it, how you're distributing and multiplying it, and make sure that you're combining like terms carefully, writing down the first names that you're adding in your calculator and keeping track of those terms.